25. And then we still have minus x squared. Is that clear to everyone, where all that came from? Okay, now collect your like terms together. How many x squareds? 3? We had 4 and then take away one of them, so 3x squared. We have minus 20x, that's the negative 10x minus 10x, and then plus 25. So this is a polynomial that represents the area of that shaded region. I'm not going to do this one. I'm just going to talk through this one. Whoa. Dyson? Where's Dyson? Dyson? I'm saying this correctly? Yes, okay. Dyson, in this problem here, they say write a polynomial that represents the perimeter of this figure. Dyson, do you know what the perimeter of an object is? It's the outsides added up, right? It's the distance around the outside. So this problem is asking you to take this side, add it to this side, and then add it to this side. So you would write, 2x squared plus 4x minus 10 plus this, and then you just collect all your like terms together, and you're done. Right? So even though it's a word problem and it's a geometric figure, this is just adding polynomials. That's all it is. Okay? Does that make sense? Mm-hmm. Okay. What about this one? The perimeter of this? Same thing, right? Just add them all up all the way around. Collect your like terms and you're done. Okay, this one says write the polynomial that represents the total number of square feet for the floor plan below. So this is like an apartment or a little, little building or something. And they want you to come up with the total area, a polynomial that represents the total area of this thing. So what I would do here is break this up into 3 different rectangles. This one, and this one. So what's the area of this one? Can you tell me what the area of that piece is right there? It's this side times this side, right? So the area of this would be 12 times this right here. X plus 6, right? And it has to be in parentheses because it's 2 terms here. You're multiplying it by 12, so the 12 has to go through to both. So that'd be the area of this. What's the area of this? Right here. It's this side, x times x plus 6, all right? You would have to distribute through. And then this last one is, well, let's see. How wide is it here? 24 times, how tall is it? It's x and then another 12. So isn't that x plus 12? And I need that in parentheses also because that's the entire side. Does that make sense? So you would have to do this distribution, that distribution, and then collect all your terms together, and that would be the end. May I continue? Yes? Okay. Greatest common factor. This thing, I wish this wasn't here. You know what? Let's not do greatest common factor. So on the review for the test that I sent out, when it asked to find the GCF, just skip that problem. We are going to do factoring in this class, but let's just do it all together at the end. They just, for some reason, they put it in here and then later on, they skip over it and then they come back to it. So we'll just start factoring from square one, and this is where we'll start. So we'll skip that for now. We are going to change gears pretty dramatically now. There's all the homework. Oh, hey, we didn't talk about volume. This word problem here. They ask you to find the volume of this box, and they tell you that the volume is length times width times height. So if I was looking for the volume, I'd have to multiply this times this times this. I'll be interested to see how you do with that factor. Okay, we're going to do percents now. What time did we go to? 1:40, right? 1:40? So let's talk about percents. Let's talk about percents. Let's start by taking a poll here. Do you remember how many students we had? I don't remember. Did I say 30? Was it 30? I think there's 30 of us. I won't count. Let's just say there's 30 of us. How many of you have an iPhone? Okay, let's go the other way. How many of you don't have an iPhone? Just raise your hand. Hold on. 1, 2, 3, 4. All in, wait, yeah, 1, 2, 3, 4, 5. 5. So 5 non-iPhones. And then that means we have 25 iPhone people in here, right? All right. So what percentage of us have iPhones?
Like 90%.
What is the exact percentage of the class that has? How are you getting that? How would you calculate the percentage?
I did like 30.
There's 30 of us total, right? And 25 of the 30 have iPhones, right? So what I would do is on my calculator, I do 25, right, have iPhones out of the 30 total. So someone do that on the calculator and tell me what that is approximately. On the calculator, though, it comes out to be what? 0.833 repeated, right? Okay, so something like that. Now, when we deal with decimals like this, if we want to convert to a percentage, what do we have to do? Times it by 100 or move the decimal point over two places. So this as a percentage turns out to be 83.3 repeated percent. All right, now percents are used all the time. We hear about, there's a 30% chance of rain, blah, 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 whatever. These percents are thrown around. We need to understand what a percent means. And percent, this symbol right here means of 100. All right, that's basically what that symbol means. To say that 83% of the class has iPhones means that if there were 100 of us in here, 83 of us would have iPhones, right? If there were 100 of us, 83 would have iPhones. Now there aren't 100, right? There's only 30 of us. But we can still use a percentage to give us an idea of how much, right? So when you're sitting here saying, what I'm trying to get you to see is that even though percents have to deal with out of 100, you actually don't have to be talking about 100 things, 100 people. Now, how many of us are smart and don't have, I'm sorry, did I say it? How many of us don't have iPhones? I'm just kidding, all right? I don't want to offend anyone. I think they both have their pros and cons. So 5 out of 30 would give us what? 16.66? Right? Percent if I converted it over. So it would give you like 0.16. I think last semester in the spring I taught this class, and I believe I was the only one who didn't have an iPhone. Everyone had an iPhone except me. All right, let's do something else. Yeah, let me see what the problems are like first. What the heck is all this stuff? Okay. I think we can get right into these, and then we'll get into the word problems. These are the basic problems that get us just working with percentages just to start. What I talked about with the iPhones was just to get us to all understand that like a percentage is out of 100. So let's look at that question right there. What percent of 200 is 21? What? What percent of 200 is 21? Now that is every time I teach this, I always have students who just go and try and figure this out without doing any math. They just kind of like calculate and they can't explain how they're getting the answer. They just do it. I want to show you how to do a problem like this in a very like systematic way. All right? We're going to take that problem, we're going to turn it into an equation, a linear equation, because that's what we just got finished doing, linear equations. So what I want you to do is read this, and each word is going to indicate something for us. So what percent, right? What percent is what we're looking for, right? We're looking for a percentage. I'm going to call that X, all right? And then we see the word of. Anytime we see the word of, we are going to convert that to multiplication. Of course, 200 is just the number 200. And then what do you think the word is? Your equal sign. And then 21 is 21. So do you see how that converts directly over to an equation? What percent of 200 is 21? What percent of 200 is 21? So this is a linear equation. Let's solve for x. This is the same as 200x equals 21. If I asked you to solve that for x, what would be the step that you take, Laura? Where's Laura? Laura, what step would you take to solve that? If we had 200 times x, so I wrote 200x equals 21. If I wanted you to get x by itself, how could you get x by itself at this point? So subtract, why are you subtracting? What's the operation between the 200 and the x right here? Multiplication. So how do we undo multiplication? You can undo addition by subtracting, but how do you undo multiplication? Division. All right, so this is important. This step right here, to get rid of the 200, we will divide this side by 200 and divide by 200. We don't subtract, and the reason why is because if you subtract 200, you can't subtract because these are not like terms. You can't take 200 away from 200x, right? This we would have to just leave that alone. So instead, because it's attached to the x with multiplication, we divide. 200 divided by 200 is 1, so we get x. And then over here on my calculator, I'm going to do 21 divided by 200. And I'm getting 0.105. And that's our answer. However, it doesn't answer the question because the question is asking what percent, right? So what's my answer then? 10.5%. So let's read the problem through again with our answer. We replace this what percent with what? 10.5? So would you agree that about 10.5% of 200 is 21? Because what would 10% of 200 be? 20, right? So 10.5% would be a little bit bigger. So this answer makes sense, all right? Let's try the next one. I keep do it all semester, I'll do that. So we've gone through all the sticks. Did anybody not get called? Because I'm taking attendance off this. Did anyone come in? You didn't get a stick?
I didn't get a stick either.
You didn't get a stick? But there's not an extra one up there or no?
There is.
There is? There's a marker there?
Yes.
Okay. Here you go.
Thank you.
And you know what that means.
There you go.
You're about to be up. Yeah, so go ahead and write. I'll take it. Thank you. Brianna, Danny. I'll let y'all can volunteer if you want. I just want this written out as an equation. So can you take what I just kind of told you in the last problem and rewrite that as an equation? Y'all, I'm letting you both figure out, whoever wants to
Not
speak.
too sure, but so wouldn't X be the number?
Yes, so the number right here is going to be x, all right? So let's go with that. The number we're looking for is x.
Kind of doing the opposite from the other one. 19.5 would be the sum for the B.
What is this going to be for us?
Equal.
Is equal. So I need equals here, right? And then your 19.5, right? And then 15%, right? 15% is going to be here. But we want to take the percent and convert it back into a decimal. So from a percent to a decimal, what would that be as a decimal? 0.15, right? So this is going to be 0.15. And then what is of? Of is going to be multiplication. All right? You all see that? So we have 0.15 x equals 19.5. And Brianna, do you feel like you participated there? Yeah.
You just divide.
Yeah, just divide both sides by 0.15. So 0.15. And at that point, you just get your calculator out. Was it Laura? So do you understand, Laura, now? Like when you have this that we're dividing by the 0.5? Okay. So we're going to divide here and then calculate. What does that come out to be on the calculator? 130 exactly? Okay. 130. So I like to read through the problem again and just see if it makes sense. 15% of 130 is 19.5. I don't know, it seems reasonable to me. What would 50% of 130 be? What would 50% of this be? Half of it, right? 15% should be even less than that. So it makes sense to have a number around 19.5. What I'm getting at is if this came out to be like, let's say your answer was like -4, like something is wrong, right? Like something is very wrong. So you want to just kind of think through it again. All right, we've gone through all the sticks, so I think that just means that we have to start over. All right, here we go. Word problems. Your favorite. Yeah. Okay, take a second to read that. I don't know if this data up here is true or not. I don't think it is, but 30% of all students at Northwest Vista College transfer to UTSA. Of these transfer students, 12% are going into biology. If there are 15,435 students at Northwest Vista College, how many of them will transfer to UTSA and major in biology? Anyone have any idea how we can go about this? Go ahead.
30% times 15,435.
Okay.
But then we have to change the 30% into decimal, right? So we divide it by 30 divided by 100, which is
30.
point,
So 0.30.
So 0.30
something. Yeah. And that'll be, what would that represent? So what's being suggested here is that we take the number of students at Northwest Vista College and multiply it by 30%, which is 0.30. That would give us what if we did that? The number of students that what? Are transferring to UTSA. Okay? And then that number, we multiply that number by 12%, and those are how many are going into biology. That makes sense? So we're going to take our total number of students here. So this is NVC right here. We have 15,435 students, right, at Northwest Vista. And then what we're going to do is we're going to try and figure out how many of these students go to UTSA. Well, how many students go to UTSA? 30%, so we take 15,435 times 0.30. That's 30% converted to a decimal, right? Which equals, let's see what that is. 15,435 times 0.3. Ooh, that's not good. Looks like we have a half of a person that they're probably not very happy, are they? Okay, that's approximately how many people transfer. Agreed? So from this group of 15,435 students, this is how many make it transferred over to UTSA, right? And then now from this group, major in biology. There's only what, 12% of this group? We have to read that carefully. Of these students, of these transfer students, of those, 12% are going into biology. Okay, so we're going to take 12% of that number. So 4,627.5 times what? 0.12. You know, sometimes people put zeros in front of the decimals. Have you all noticed that? Sometimes they'll just do 0.12, sometimes they'll do 0.12. The reason they do it is exactly for something like this. This just looks weird, doesn't it? But if you write 4,627.5 times 0.12, that zero kind of creates this buffer between this dot and this dot so that it just doesn't look strange. All right, so I do that number times 0.12, and I get 555.3 students. Make sense? Okay, I have another question for you, not from up here. This is a question. This is something that actually came up once for me. I was at I think I was at Lowe's. You know what I'm talking about? The yes. Pardon. It's very possible I did the wrong thing here. Did y'all get something different?
It's like 3 numbers off.
Well, that's significant. Fine.
I mean, it's still.
15. Oh no, no, thank you for saying. I typed this in wrong. I put 15,425 instead of 35. Yeah, y'all just make sure y'all say something. 15,435 times. Yeah, but I want to. Okay, so sorry, that middle number should have been 4,630, right? 0.5? Sorry about that. That middle one was this one. And then that next one over here times 0.12. Come on. 555.66? Okay, yes, thank you. 66. This one was 4,630. Yeah, I just messed up the number. All right, so I was at Lowe's once with my dad, and my dad is retired military, so he gets 10% off, right, his purchases. But then we also had a 10% off coupon, okay? Y'all with me?
Yes.
And then we had a 20% off coupon, right? So here's the deal. They'll only let you use one coupon, right? And the 20%, you couldn't use the military discount. So the question becomes, we could do one of two things. And I think we were buying like a washer or dryer or a set, so the total was like several $1,000s. Let's just, for the sake of demonstration, let's say that we were buying $3,000 worth of stuff, let's just say. Our two options were to take off 10% and then another 10% with the coupon, or we could do 20% coupon only. So which one do you do? Or are they the same? Are they the same or are they not the same? It all depends on the way they calculate it, right? So here's the way that Lowe's calculated this. What they did for this scenario is they took 3,000 and they took off 10%. How could I figure that out on my calculator? So for this first step, I could do 3,000 times 0.10 would tell me what 10% off is, right? But why don't we do it a little different? And this is something I suggest you do if you ever are doing money computations. If you want to figure out how much something costs, if there's a certain percent off, don't multiply and try and figure out how much is off. Just multiply by how much you have to pay for. So if they take off 10%, how much of it do I have to pay for? 90% of it. So multiply it times 0.9 instead. And that'll give you how much you're paying, right? So I'm going to multiply this by 0.9. So we had 3,000 times 0.9. So that reduced our total down. I'll do the 20% of it in a second. This reduced our total down to $2,700. Okay? So they did that, and then they gave us 10% off of that. So they took the 2,700 and they give us another 10% off, so I can multiply that by what? 0.9 again. And it comes out to be $2,430. Okay? So that's the amount that we were going to pay if we used the military followed by the 10%. Okay? Now, the other way was to do the 20% off. So 3,000, the 20% off. How could I calculate that? 3,000 times what? 0.8. 0, or 0.8. So 3,000, what's that? $2,400. So this was better to use the 20% coupon. It saved us 30 bucks. You know what I'm saying? It's 30 bucks, it's 30 bucks, right? So even though two 10% coupons may appear to be the same as one 20% coupon, depending on how they calculate it, if you do it individually, you're actually going to pay more, all right? All right, let's do another word problem here. Let's look at number 8. I'm going to pass this around. This is the sign-in sheet. I could take attendance off of the sticks, but I don't. I want to at least make sure everyone has signed in one time, and I know some people weren't here last time. Our test next class, I will plan on. I'll send you an email later today telling you what to look at on the review, because we're not going to cover everything on that review. And then we'll start class off the first 15, 20 minutes me answering questions. And then we'll take the test. I'm going to give everyone the same amount of time for the test. When the test is over, we're going to continue class. I mean, it'll probably only be for like 30 minutes. And that'll suck, but that's what we have to do in the summer. We can't just come in and spend the whole day taking a test. All right. Look at this question here. Is that the same question I just put up on the board?
Yeah, but this one doesn't have the actual students at Northwest Vista.
That's right.
Say 30%.
Yeah. So what it's saying here is that you've got all the students at Northwest Vista, 30% go over to UTSA, 12% of those students go on to major in biology. What percentage of the students that are going to UTSA, what percentage of Northwest Vista students are actually going to UTSA to become biology majors? So we don't have the 15,000 anymore, do we? So how do we do this then?
We use the X.
We can use a variable, exactly. So let's let S be equal to the number of students at Northwest Vista. Good, all right? Let's S for students, all right? That's the number of students at Northwest Vista. How many of them are going over to UTSA? 30%. So if I take this and go 0.30 or 0.3 times S, this is equal to the number of students transferring, right? To UTSA. Okay, how many of those students are going to go into biology? 12%. So I have to take that and multiply that by 0.12. So if I do 0.12 times 0.30 times S, this is going to be the biology. So on your calculator, let's do that. 0.12 times 0.3 is 0.036S, right? So who can figure out from that what the percentage is then? It's 3.6%. See, because this is how many students wound up at UTSA in biology, right? It's not the original S, which would have been 1S, right? It's not all of them, that's 1S. It's 0.036 of them. So you convert this number right here into a percentage, and you get 3.6%. Does that make sense? Using that same sort of, yeah, okay, we'll just leave it at that. See what other kind of word problems there are here. Last one. This will be our last one. We'll call it a day. In a Gallup poll, 976 adults, 18 said they drink alcohol every day. 68. Thank you. I don't know why I said 18. You know why I said 18? Because it says adults here, and I'm not quite sure what they mean by adults, right? Like, do they mean 18 or 21? Like, isn't 18 you're an adult? But you're supposed to be 21 when you drink, so, okay. Whatever. Their poll says of the 976 adults that they polled, 68 of them say they drink alcohol every day. What is the percentage of respondents who said they have a drink every day? So this is not a complicated or difficult problem. All you're trying to do is figure out what percentage say they actually drink every day. So this is kind of like the iPhone problem we did to start this whole idea out. You want to make a fraction of the number of people who drink every day, right? 68 drink daily, divided by what? The total number that you have in the poll. And whatever that is a decimal, you then convert to a percentage. So we don't want to overcomplicate the problem. This turns out to be approximately 0.0697, approximately 6.97%. And on your test, I'm not going to be real big on the rounding. If you want to round that to like 0.07, that would be fine. And say 7%, I'd be happy with that. All right. So your task for the weekend and for Monday is just to go through, make sure you understand the homework, take a look at the review that I put online. I probably will not post solutions to the review because you have solutions to the homework. But if you're really stuck on a problem, I'd like for you to reach out to me, text me, show me a picture of your work, because I would rather you kind of be stuck and me help you than for me to just give you the answers, all right? I might give you just the answers at some point, but not right away. And then just be ready on Monday, all right? It'll be about the same length as the review, which I don't remember how many questions there are.
You said you're gonna email us this later.
I've already emailed you the review.
What about the ones you don't want?
I'll email you later which problems to omit from that. And so if the review's 15 problems and I take out 3 or 4 of them, then yours would be, 12, 11 or 12 problems. What's that? The review is not a homework problem, or is not a homework set. It's just for practice for yourself.